This video is on algebraic proofs, more of them than the previous video. We're going to start with an example of an equation that has variables on both sides of the equal sign. So if you'll take a look here, you'll notice that we have a 6x on the left side of the equal sign and a 2x on the right side of the equal sign. Those of you that are more comfortable with it, remember you can always draw a line down the middle so that you keep the left and the right side sort of straight. So to begin with, you can't just combine like terms when the terms are on different sides of the equal sign. Anytime you want to change the side, you have to change the sign. So you do the opposite, just like you would get rid of this plus 4 by minusing 4 or subtracting 4 to both sides. Let's say we want to get all our x's over to the left. Well, that means I want to move this 2x. If I want to change it to the other side, I have to change the sign. It is a positive 2x because there's nothing in front of it. So I'm going to minus 2x. And that's going to make 0, which is great. That means it'll be gone. But what I do to one side, I do to the other. Now notice where I lined that up. It's under the x term because those are like terms. You have to be careful that you line things up under the same kind of term. And so step 2 is going to be 6x minus 2x is 4x plus 4. Now these cancel because they make 0. 0x is just 0. And don't lose this negative here. This is equal to negative 8. All right, so what did we do? What's our reason? How did we get here? It's still subtraction. Look, you subtracted 2x from both sides. So this is the subtraction property. Okay, and then now we need to look again at what you have to do. Now look, the x's are all together. They're over here. There's no other x's in the problem. You can do the rest exactly the way you have been. Minus 4 to both sides. We get 4x. Those go away. Equals. And here you get negative 12. Be careful. Use your calculator. So again, what did you do to get to line 3? The work in between, what I have in green, was subtraction. And so you can see that you might use a property more than once in an equation. We have a little delay going on there. All right, so to get to step 4, I have to look at step 3 and say, what do I need to do now? Remember to keep your eye on the ball. You want x by itself. So what's happening is it's being multiplied by 4. To get rid of that, you're going to divide by 4. What you do to one side, you do to the other. 4 over 4 is 1. It cancels, and I have x equals negative 3. Watch your signs. And so what did I do to get here? I divided. And so this is division property. So you can see that when you have a variable on both sides of the equation, there's just an extra step to move them onto the same side of the equation. Go ahead and pause the video and try this one now. Okay, take a minute to check your work. Pause the video again here if you need to. The lines in black are my steps, each with a reason, and the work in green is just that. It's the work that happens in between the steps. All right, now we're going to do an example with more than one fraction in it. And I know that fractions tend to make you nervous, but remember, we're going to get rid of them. So to do it, we're going to do this one example together. Now you can't just multiply everything by the denominator, which is what you were doing to get rid of a fraction. Because the problem is I have two different denominators, so which one is the question? The answer is take your denominators and multiply them together. What you're really looking for is a common denominator, but a quick way of doing that, and you won't always get the lowest number, but a quick way of finding a common denominator is just to multiply them together. So I have two denominators in this problem, a 2 and a 5. And what I'm going to do is multiply those together. It makes 10. And I have to multiply every piece of this problem by 10. So 10 times the 6, 10 times negative 1/2, I'm going to stick it up here, and 10 times the 3/5. Now, you have to multiply it to every term. But remember, your calculator will do the work for you. So it looks funny, but you can then go to your calculator and do this multiplication with the fractions. So 10 times 6 is 60. And now you go into your calculator and you do 10 times negative, because it's with the 1/2, 10 times negative 1/2, and you're going to get negative 5x. And now you're going to go in your calculator and you're going to do 3/5 times 10, and you're going to get 6. So look at what we have. Remember what I told you, it's like magic, but it's not. It's math. So it feels like a trick, but what you've done in the last step to get to line 2 is multiply, right? You just have to remember to be fair. In math, you have to, if you do it to one thing, you have to do it to everything. And so don't leave any terms out. Every single piece of your equation has to get multiplied. This is a problem that you can finish on your own, and I'd like you to pause the video and try it now. Okay, how did you do? I was a little worried that maybe you would try and move this just because it comes second in the equation. Did you do that? Remember, if you made that mistake, the idea is leave the x alone. The only time you want to do anything with a term that has an x in it is if you have an x on both sides of the equation and you need to get them on one side together. Otherwise, you leave the x alone, you don't move it. Also at the end here, this fraction, you'd put it in your calculator. It doesn't reduce necessarily, but negative divided by negative is positive. So notice my answer is positive. You may leave an improper fraction such as this. I don't really even want you to turn it into a mixed number. So here's some steps to get rid of the denominator. Some of you really like to see this in words, and so this is what to do. You start by choosing a common denominator, and I told you you can do that just by multiplying any denominators in the problem together. Then you have to multiply every term in the equation by that common denominator. Every term, notice it's highlighted. Reduce each term to form a denominator-free equation. Basically, get rid of the fractions. So don't get freaked out by reducing these terms because you're going to multiply everything in your calculator. And so the fractions will go away because the calculator is going to tell you. I hope you can do that by hand, but at this point, let the calculator help you get past that part of it. So I want to try another one here, and just to get you started, remember that you want to multiply your fraction denominators together for a common denominator. So if you look at this, they're both fractions, but 6 times 10 is 60. So you're going to take and you're going to multiply 60 on this side of the problem, and you have a term here, you'll multiply 60 to that also. Guys, do it in your calculator. 60 times 9, 6. When you put that in your calculator, it's going to tell you 90. And the same thing is going to happen on this side, but now be careful. You can't put the x in the calculator. This is 60 times 1/10. There's like a 1 there, or you can just do 60 over or divided by 10. The 60 is on top, the 10 is on the bottom. Reduce that and you're going to get 6x. Now that might be a little bit confusing for you, so we'll go over another one of those in class. What did you do? You multiplied. Everywhere here, multiplication property. And then, of course, keep in mind what you're trying to do. You're trying to get x by itself. You're not going to do anything to that 90. You need to get rid of the 6 that's in front of the x. It's being multiplied. To get rid of it, you divide. And what you do to one side, you do to the other. Now, this looks a little backwards, but I don't want you to worry about that because it's okay. You're going to get the x on this side. It's all right, it doesn't matter. You put 90 over 6 in your calculator and you get 15. And the way that you got that was dividing. You divided on both sides, so division property. So the part that I expect might hold you up a little bit is right here, this x over 10 times 60. So we're going to talk about that part more in class. The last type of equation we're going to solve is not really an equation, but an inequality. And an inequality, the only difference in working them is that there's an inequality symbol instead of an equal sign. And so when you work these problems, you're going to do them the same way. There is one little trick with inequalities, and I'm going to forward to it. If in the problem you ever have to divide by a negative, this is just for inequalities now, you change the direction of the symbol. So look down here at the bottom to see what I mean. I have negative 3x is less than 12. Okay, so you know that if you got to this point of the equation that you would be dividing by negative 3. And this is the rule right here. When you divide by a negative, you do everything the same way you've been as far as the math, but you change. Look at this is less than, look at how it changed. Now it's greater than. That is the only rule that's different with inequalities. Otherwise, you just keep the symbol instead of the equal sign, and you follow through the whole way. In the end, if you divide by a negative, flip that sign around to point in the other direction, and everything will turn out great. So I want you to, on your own paper, do this one, and we'll go over the answer in class. And there's one more here that's a little harder, and I just want to make sure I can get you started so that when you do this, you know what to do with the parentheses. If you recall, when you have a number in front of parentheses, it's being multiplied, but you have to do it to everything in the parentheses. So this is negative 3 times p, and then you also do negative 3 times positive 1. And negative 3 times positive 1 is negative 3. You write it down and you just finish writing the rest of the equation. So this is distributing, and so your reason for this would be the distributive property. And again here I want you to finish this inequality. It's something that you can do. Keep your eye out for dividing by a negative. If you get to the point of the problem where you have to divide by a negative number, any negative number, you have to change the direction of this symbol here and make it point the other way. Finish the problem and we'll check this in class. Don't get discouraged here. There's another one. We'll do this one in class together. I'm not going to have you worry about it right this second. Look, you've done a good job. This is a lot of hard work, but keep at it. I promise you're going to